Hello everybody and welcome. Today we will be introducing a new term which is called impulse. Well, actually it's not very new, it's very much related to momentum. Now, if we want to introduce what impulse means, we can say that it is a term used to describe how much a force changes the momentum of an object. So actually here we are just relating force to momentum in a way or another. Now, for example, if you push or pull an object, you will apply a force on it, correct? Now, the longer you apply that force, the more the object's momentum changes. We can actually relate that by the following. We already know that according to Newton's second law, force is equal to mass multiplied by acceleration. So if we are applying the force for a longer time, we are increasing the acceleration. And the larger the acceleration, we know that this leads to larger velocity. And the larger the velocity, this leads to larger momentum. So actually it's very much related and it's common sense. Another example, we can say that imagine you are playing football and you kick the ball with all your strength. Now, if you kick the ball for a short time, it won't go very far because the force acted on it only for a short moment. But if you kick the ball for a longer time, the force will act on it for a longer period and the ball will go much farther. Okay? Another explanation for impulse, we can say that it is simply the change in momentum. The change in momentum. Remember we said always the word change relates to delta. So we can say it's simply delta momentum. And that's what we use to describe impulse. We can say it's delta momentum. It can be given in actually two equations. The first one says that the delta P, or the momentum, it's equal to force multiplied by the change in time. So this is the first equation to find the impulse. Or we can say that impulse is equal to mv final minus mv initial. In other words, we can say that it is p final minus p initial. Let's write it down here. We can say delta p, it's equal to p final minus p initial, and we already know that p is equal to mv final minus mv initial. Okay, now what is the relationship between this equation right here, f delta t, and mv final minus mv initial? Let's try it right here. We said that delta p is equal to force multiplied by change in time. Now, we already know from Newton's second law that force is equal to mass multiplied by acceleration. So we can say that m multiplied by a multiplied by delta t, it's going to give me the equation of impulse. Okay, we also know that the acceleration, it's equal to, here, let's write it right here. We introduced that a long time ago. We said that delta v over delta t is going to give me acceleration. So I can say, in other words, that mass multiplied by delta v over delta t multiplied by delta t, it's going to give me impulse. So we can get rid of delta t with delta t. So now we have m delta v. We can say that m delta v, it's going to give me the delta p, right? And if we want to simplify it even more, we know that delta v, it's equal to v final minus v initial. So we can say that m v final minus v initial, and we can just rearrange the equation. It will become mv final minus mv initial, which is this equation, or the first equation right here. So this is just a simple proof that force multiplied by time is equal to the change in momentum. Actually, we kind of finished what we want to talk about in this chapter, so the next videos will be solving a lot of problems about momentum and impulse, so stay tuned.